Good morning. Another lecture in our EPICS training series. This one is mostly for internal ASD controls use, but it may be of use to others from BCDA or even outside, but I suspect most likely it's an internals thing. So iocappsTools, I'm going to be talking about what they are, a little bit about how they connect to or rely on the APS accelerator standards for our IOC's ASD standard support module, and making use of ERMIS, and we even have touch on AOIs, which I can't remember what that acronym stands for nowadays. And so I'm going to be covering this list of tools here, which is not the complete list. There are a few others that I'm not mentioning. They are a little more obscure. There's one particular one on starting and killing off soft IOCs that you guys may know more about than I do, and I couldn't experiment with yesterday when I was finishing off the lecture anyway. So, okay, so iocappsTools, this is an EPICS extension. So it installs into our scripts into our standard extensions bin directory, and it provides scripts basically for querying, configuring, and interacting with IOCs. As I said, most of them were designed for use here at the APS with the accelerator systems. I believe they can be used at BCDA now that you guys are using ASD standards. So there are some things that you might be able to make use of, but some that you can't, because some of these tools rely on ERMIS, and I don't believe you guys are running ERMIS crawler over in the beamlines. But so the IOCs must be using that ASD standard module to provide the data for the scripts to use. I guess there's probably one or two tools that you might be able to use without them. For instance, the error log script and maybe IOC console, and maybe one or two others. But most of them will rely on ASD standard and our file system layout as well. You can actually move where we put the file system in most cases, but it still needs to be roughly the same layout. And as I said, many of the tools connect to the ERMIS database for querying about which IOCs are production IOCs, and or which ones are not in use, that kind of thing. If you want to use them and those tools that rely on the file system path, usually you can set a single environment variable to change that path if they happen to be. If your copy is in a different location, not at user local IOC apps. In most cases, operations using these tools, you can actually query or talk to, ask about multiple IOCs or multiple records at once. And some of them you have to go one by one, but in most cases you can sort of specify a pattern or a list. So the simplest application is IOC help, that basically does nothing but print this list. I cut off. There's quite a few more below there. So basically prints you a summary of list of what all the scripts are and what they do. IOC help, IOC apps help is also a synonym for the same thing. So if you can't remember which tool does what you want, IOC help will tell you that. Probably the most used tool is IOC console. The idea of this is to open a terminal session to the console of a particular named IOC. And under the hood, this uses a program called Screen from GNU, which actually allows multiple users to connect to the same screens at once. And you can also use this to switch between screen sessions. So you can use Screen on your own without dealing with this if you want to run multiple sessions in the same terminal window. You can run Screen and say, start me a new terminal, and you switch to the other terminal in the same screen window. Mostly we don't make use of that, but IOC console uses Screen to allow the multiple users to connect at the same time, so that if you happen to leave the screen open in your office, you can still connect to it from home if you need to overnight. And the program, when it starts up, it consults a series of configuration files to work out how to actually connect to the IOC. It's not burned into the program. You can override the locations for where it actually looks with a couple of environment variables. IOC info, that's the standard one for all the other IOC info stuff. But IOC screen can also affect that. If you need to use those, I should probably look at the source code, because I forget exactly what the details are. You can also provide detailed connection information on the command line. So if you're trying to connect to, say, a Moxa box that's not in the system, you can actually use IOC console and give it the information telling it how to connect to the Moxa. But I'm not going to give you the detailed information on what those arguments are. There is some help to IOC console, which may provide some of that information. The idea is then it can connect to console ports over various different protocols. Usually it's over Telnet or SSH. The terminal concentrators that IT use for the accelerator IOCs typically are using SSH, secure shell, whereas Moxa devices tend to use Telnet and a specific port number. So IOC shell can cope with all that if you just configure the file, and it will work out how to make the connection. For some of our IOC, for the accelerator IOCs at least, IOC console will also connect to the ERMIS database in order to pull out special instructions we have on IOCs about the pre-boot and post-boot and display those to you in case there are special instructions on if you connect to this IOC, do not reboot it because you'll drop beam or something like that. So those kinds of things are displayed just before it actually runs GNU screen and shows you the connection, just to get you to acknowledge those instructions. Once you're actually in there, then basically your interaction is with GNU screen itself, and screen has many features. You can do copy and paste, and you can scroll around the history buffer and so on. The easiest way to work out what that can do, Control A and then question mark will print a help screen, and that will give you some idea as to what other sorts of things that you can do. When you exit an IOC console session, what you actually want to do is disconnect, Control A and then D. There are other ways that will actually end up closing GNU screen, Control A K, which is the kill, or Control A /, which is the regular exit. Those will actually stop screen running, and it will then destroy all your console history. So you probably don't want to use those. That's why we just use disconnect. Control AD is how to exit IOC console. That's pretty much all I'm going to show on that one. I can't really demonstrate this too much. I couldn't show a screen session because it's mostly just showing you what the IOC looks like, which is not really IOC console itself. So, move on to some of the other CAPR. This is a nice, useful little tool. It's basically a channel access version of the IOC's database print record utility, but you can do it remotely. There is actually a version of CAPR included. It's called capr.pl, and it's actually included in base. It's been there since 3.14.12. So even if you don't have the iocappsTools, you can use CAPR. And you give that just as with the dbpr command. You give that two arguments: a process variable name. The second argument is optional, and that will be an interest level, which defaults to 0. But if you increase that, you get more and more fields displayed. And we see the example down there, sorts of things. This is a level 0 on a record type, which is a calc, so it shows you only a few fields. Now, internally, CAPR uses its own list of record types and the fields that belong to that record type. So it's possible you may try and print a record type that CAPR doesn't know about. And in that case, then you can actually point it to your own IOC's DBD file instead. You basically say -d and give the path to that DBD file, and that will then show that will then tell CAPR about all the record types and fields in that particular for that particular IOC. So if there are record types that you've added that CAPR doesn't know about, you have a way of getting around them. You can also use the CAPR -r command for the list of records, so that'll tell you all the record types that it knows about. If you find any that are in common use, installed in the accelerator at least, which aren't in there, then we should probably add them to the CAPR database, the DBD file. So let us know. But that's a useful little tool if you don't want to actually log into the IOC console, or you can't get to it, or something like that. You still have a channel access connection. So it actually prints you out where the path is to its DVD file. While we're talking about accessing PVs, process variables, the tool pvexist is useful if you know part of a name but you don't know the full name. You can use pvexist and give it the part of the name that you know, and it will actually look through the PV data files that all the IOCs generate and grep through those and give you a list of all the record names that it can find that match that particular string. As before, this uses that IOC info environment variable to actually tell it where to find the IOC info PV data files. So you can override that in your own if you're using this somewhere else. And basically, you can take a list of strings. It can be more than one string. And you can also provide regular expressions. You probably want to put those inside quotes, so the shell doesn't change the things you're looking for, but so that you can actually look for some fairly complex things. It's basically running grep underneath. So, for example, here if I'm running pvexist and asking it for storage ring current or current CC, and I know somewhere in there is the list, some of the PVs that I might be looking for. The output that it actually shows here is not particularly friendly. What we've actually got here is a concatenation of the IOC name and a colon followed by the PV name. So the line contains more than just a PV name, and you have to ignore the IOC name colon part, and then the name starts immediately after that colon. But that's how the tool currently displays the output. So you can see there, I'm looking for these two. And actually, it does the searches sequentially. So it searched for SR current first and printed the three matching PV names under SR current. And then it went on and found the current CC ones. There's a one space indent, which you can actually just about see to say, okay, that was the end of that search. This is the start of the next one. So that's pvexist. Probably one of the other main used tools is this script called ioc-boot, which actually has rather more options and looks like it could be more useful than I ever thought it was when I was looking at it to work on this presentation. So ioc-boot, its main task is to display what the current boot parameters are and the boot history and all the boot history for a set of IOCs. As before, it normally uses our user local IOC apps area, but you can override that by setting the IOC info environment variable. It's not just for VxWorks IOCs, it also handles RTEMs and soft IOCs, as long as they're using the same ASD standard module. It basically displays a different set of boot parameters that's appropriate for whatever the IOC type is. You can also pass in an option -s if you don't really want the full-blown list of boot parameters. -s tells it just display the startup script, the path to the startup script, and nothing else. And that's often all you need. So sometimes that can be useful to cut down on the output. In some cases, for some of the kinds of queries, it makes requests to ERMIS to look up what are the list of active IOCs. And in that case, you can actually change what it actually uses. If you don't want active IOCs, but you just want production IOCs, production systems, then you can use -p. I'm not sure whether there's as much of a distinction between production and active IOCs now in ERMIS. I know that a while back we were fairly careful that this is a production, this is just an active, but it may not be needed for the system to run. So I think that was the distinction between them. But I'm not sure whether that part of ERMIS is being kept up to date as much as it used to, but hopefully it is. So ioc-boot then has 4 different modes of operation depending upon what the command line arguments you give it. So if you give it a list of IOC names, it basically displays you the boot parameters and the boot log for those IOCs. That's fair. That's the sort of the typical standard operation that most of us use most of the time. But then there is an option -n, which tells it display the boot parameters and the boot log only for those IOCs that are not booted in the official area. So an IOC boot -n basically tells you everybody who's got IOCs booting out of their development, their home development areas and not out of the official area. So that's a useful thing to know. I'll show you an example of that in a minute. You can also specify, instead of the -n or the IOC name, you can specify a date. Actually, I think you can specify the date with the IOC names as well. And then that tells IOC boot, just display me all the boot log messages only for the IOCs that have booted since midnight on that particular date. So you can see how many IOCs have had to be rebooted since the maintenance period on Tuesday, say, or something like that. You can also add a minus sign after the date, in which case that displays the names, but not the boot log information, the names of all the IOCs that have not been booted since that particular date. So that's how you can use this to find out what IOCs have we not rebooted at the end of this shutdown yet. So you can say everything should have been rebooted at this period, show me all the ones that didn't. So I have some examples now, and let's make those a little bit clearer. So here's our canonical standard use. I want to find out boot information on IOCRF time. I just type IOC boot and IOCRF time. And this is a VxWorks IOC, so we get the typical VxWorks boot parameters there and the last 10 or so boot log messages from that particular IOC. If we go to a non-VxWorks IOC, we have basically the same thing, except the boot parameters are different. I said they're appropriate to the particular kind of IOC that you're talking to. Here we're looking at one of those other options. So here I'm using the -n option. I also added the -s and -p just to cut down on the information that it's displayed. But fundamentally, I'm showing here the use of IOC boot -n, and that's saying these are the production IOCs, so it's -p, production IOCs that are booting from developer trees, i.e. not from the system area. So as of yesterday, we had about 11 or so IOCs in that state. So -n then says not booting from the official area. P says I'm only interested in the production IOCs, and the S says only give me the startup script. So that's why we don't get the same display as we did in the previous ones there, because I've only said I only want the startup script. So that cuts down on how much we see, and that's usually for this sort of usage. That's one of the main purposes probably. And my final example is IOCs that have rebooted since a particular date. So here I'm specifying a date, IOC boot with a date, and what that's showing me is everything that's rebooted since then. So it looks like we had an event on Tuesday where Tony had to go through and reboot a whole load of BPM systems and so on for some event system. There were loads and loads of these, so can give a long list. But as I said, this doesn't actually show exactly the same information. It only shows the boot log, not the boot parameters. We're not interested in the boot parameters necessarily in this case. So those are a couple of new uses for IOC boot that might be helpful in some cases. IOC boot change. This is a script that can be used to modify the VxWorks boot parameters for a set of IOCs. And the idea is for each IOC, it actually basically manually goes through and connects to the IOC console, sends a control XYZ, which resets the VME CPU, brings it up into the boot ROM, stops the boot count down, sends the C command and changes the boot parameters. And then after it's modified them according to the commands that it's been told to do, it then sends the at command, which boots VxWorks, boots the IOC, and then it disconnects and then starts again for the next IOC in the list. Now, within that section, there are various things like it'll prompt you for, yes, do you want to do this, and so on, but that's basically the loop that it runs for each of the IOCs that you've asked it to work on. And there are various options that you can give it for things that you want to change. Say I want to switch to a new version, a new internal release of a VxWorks image, so switch from ASD6 to ASD7 or something like that. I can use -F to switch that release version, or I may want to switch to a completely new path, VxWorks boot image path, so I can use -V to specify that path name. Obviously, you want to make sure that you only run IOCs that have the same CPU type, an OS version, when you're doing this. We can also switch Epic's base versions, so if we're upgrading a set of IOCs, say you're upgrading all the app storage ring power supply IOCs or something like that from 3.14.12.3 to 3.14.12.5, you could use this with the -S option and say, okay, I'm switching all those to that. You might also need to change the branch of your IOC application version number. Branch version number, that will be the -B switch, -B3, say, to go update from 2 to 3. And you can also change the top application directory as well. -T will be set the top, and that really only affects the startup script. But again, that can completely change where the IOC is booting, is getting its application from. Now, okay, so this script, it's written in Tickle. It's not a Perl script. It's kind of a little bit more complicated. It was written by Eric Norum when he was here. This is a pretty expert level tool. It can be rather temperamental. I think we discovered when we switched from running it on Solaris to sort of running it on Linux, it didn't quite work. So it can be dangerous, and there are a few safeguards built in. But as I said, it's pretty much an expert level tool. So if you're going to need to use this at all, I would go and talk to Marty Smith before you actually try it. It's a bit sort of string and sealing wax type on how it works. So, but there are times when we really need it, and if you're making major changes to a lot of IOCs, then this tool is a godsend. Okay, IOC BSP. So this tool exists to answer basically one question: is I have an application built against some particular version of release of base which is installed, and the question it's answering is which IOC boot image file do I want to boot my VxWorks, my VME CPU against? And so you can specify the release, and it'll just print you out a list of all the boot images, or the latest version of the boot images that are compatible with that particular release. If you only want one, if you know that you're only booting a 5100, say, you can add that as a second argument after the release version number, and it will only print out that version. You can also specify -A, and it'll then list all the different ASD or dev versions that are compatible with this particular 3.14.12.3 or whatever release of base. So it's a simple tool. It could, it wouldn't have to exist. It could be done by documentation, but this basically queries. It saves us having to update documentation all the time. It just basically queries, looks at what files are there, and works out what the best ones will be. Yeah. Another question that, as a developer, you might want to ask are, I'm switching to a new version of base. What is the latest versions for a set of support modules that are built in the production area for my particular set of applications that I'm wanting to use? So we run IOC modules. We tell it which release of base we're using, and then you can give it a list of support modules. So here I'm saying, I want to know what the latest versions of IPAC ASIN and DirectNet ASIN are, because I'm wanting to use those in a new IOC, say. So I run that, and it basically gives me, it prints up the IOC apps line, which is a useful shorthand, and then for each of the modules I've asked for, it tells me what the latest versions are. So the idea is you should be able to just copy this list and cut and paste it directly into your release file. For some reason, this doesn't actually include Epic's base in the list, but I guess you could probably even mention Epic's base on the command line there. I haven't actually tried that. It probably should do that automatically, but currently it doesn't. If you happen to be working with 3.13 IOCs, not that we are anymore, but there's a an older tool called IOC support, which we use instead of IOC modules for back then, but the IOC modules is the new version. Support files had a slightly different path to all the release files, so we rewrote the tool. Related to that is another tool called IOC find support, which basically answers the question, I know there's a particular driver somewhere installed for that particular module, but I don't know where it is. I don't know what it's called. And so the idea here is that I can run IOC find support, and I'm saying somewhere in there are some files that have TVME200 in them. And what it does, and I'm looking for in 3.14.12.3, say. And it will actually go through the file system under 3.14.12.3 and search for that string, that first argument that I gave it, in all the file names, in all the files under iocappsTools 3.14.12.3, and print out the list of all those files. So if you do something common, then you'll get a huge number of outputs. But in this case, I discovered that there are only 2 files that have TVME200 in. So that's how you find out that, oh yeah, I need to use the IPAC module, and there's a couple of different versions available. So that second argument, the release number, you can leave that out, in which case it'll search all the Epix releases. You can specify a single release version. Unfortunately, you can't specify more than one release version. But you can specify an absolute path name or multiple absolute path names for directory trees for it to search instead. So you can always use that instead of if you want to search multiple releases at the same time. One point to note there, if you get no answers whatsoever because the string may be buried inside the file, then you can add the -t option, and what that does is it actually tells it to grep through the text of the files. Those are the files that are not binaries, and not just the names of them. But that will be a lot slower, so I really don't recommend doing that until you've exhausted all other avenues using the without the T. I mean, this sort of thing you can ask people as well, but this might be faster in some circumstances. So it's a useful little tool that somebody obviously wanted at one point. Okay, now we're getting onto tools which are making a bit more use of ERMIS. And here, PV usage, the idea of this script is I want to know what records or even other channel access clients connect to these PVs. So you can do this through the ERMIS website, through the ERMIS web front end, but this actually allows you to make some of those queries directly from the command line. So PV usage, and you can specify, and here I'm specifying a pattern. There's a % up there, which is equivalent to a wildcard, a star, in many cases. So here I've said I'm looking for this particular pattern, and the output that I get back is all the list of all the PV links that are connected to records with this pattern. So there's 4 of those on 2 different IOCs. But then I also get a list of all the channel access clients that are connected to it. So a set of MEDM screens with the PV names that match them. So as I said, you can give it a list of PV names or partial PV names using % for wildcard, and this actually queries ERMIS directly and shows you the results. So it saves you having to run up the ERMIS web page and that sort of stuff. IOC network. One of the other ERMIS queries that I know that I've done before is what are my network connections for this particular IOC or for a set of IOCs. And so IOC network will answer this question. Again, I'm using a % sign here, IOC % time. So % is my wildcard. So it gives me responses for IOC INJ time, M time, RF time, and there was another one, S35 time, I think, also matches that pattern. So it basically tells us what the terminal servers are and how their Ethernet connections connected into the network. So if you need that, that saves you that can save you having to run up ERMIS to get that information. And it's querying ERMIS, so it should be as up to date as the rest of as the ERMIS web tool. And one more tool here, which there's a note on the bottom here, but IOC error log. So all the IOCs that are configured to do so log their error messages to error log servers. And the purpose of this tool is actually to be able to query those logs and print most recent messages logging for those particular IOCs. You can specify a date if you want to limit the output to only see messages since that particular date. By default, it only prints you the last 10 messages, and both the number and the date restrict the number of things that it prints, but sometimes you might want to use both. So here I'm saying, show me the error log messages from IOC SMPS since February 3rd, and there I get 4 messages there. While I was doing this, I noted that it looks like the accelerator IOC log servers have been offline since the 5th of February. I'm not sure whose responsibility that is, but somebody in controls probably needs to go and work out why the IOC log servers have been stopped. According to the information that I can see in the README, that was on a machine called Athena, but Athena doesn't exist in the accelerator network anymore, so I don't know who's responsible for that, but somebody, I'm guessing Scott, you should probably take that on as a task to go and find out what's going on with those log servers. A couple more, these are a little bit more obscure, and I'm not sure whether you guys are really using AOIs much anymore. If you want to find out, I can remember part of an AOI name, but I don't remember the full thing. So AOI basically exists it has 2 tasks. You can either query which AOIs contain this particular string. So here I'm looking which AOIs have ASD standard in them, and that's my list. Or in my second example here, which AOIs are associated with a particular PV. In the second one, you can use wildcards, but I don't think you can with the AOI names. I'm not sure. But so in this case, I've used a wildcard. I've said that same PV name that we looked at before. What's the AOI associated with it? And it found me. There's one AOI storage ring ID 4 and so on. So if you need to know what AOI names are. AOI, okay. AOIs, I think the original name stood for something like applications of interest, but I think they basically turned it into one of these acronyms that didn't have a meaning since then. That was something that Debbie Kwok worked on. What happens is all the IOCs that are using AOIs, they have comments in their startup scripts which flag the ERMIS crawler, and the crawler says, okay, here's the start of an AOI. And from that point, all database files that get loaded until the end marking in the startup script are said all those records are associated with this particular application of interest. So in this case, I've said we have ASD standards. So there are applications. There are 6 applications of interest there, and they're sort of a hierarchical. So ASD standard incorporates all those ones below it. And so if I wanted to find, I can it's possible to do ERMIS queries. I'm not sure, I don't think we have a command line for this, but you can actually find the PVs associated with a particular AOI. Usually you want to go the other way around, but AOIs have associated, as we'll see in a moment, have associated MEDM screens, so you can say this is an application, this is the storage ring. In this case, this is something associated with the storage ring insertion device. I'm not sure how that 4 motor matches those, but anyway, it's related to 1DS. So this is an application of interest that will include all those PVs. And if I go on to my next slide, there's a tool that you can use to actually say open an MEDM screen for a particular AOI. or list them. And so in this case, the example here, I'm just listing them, but if I didn't have the -L option there, it would have actually run ADM and loaded those two ADL files for me. And so I could then say, okay, here's an application, show me the top level screens, and those screens have also been marked in ERMIS as associated with this particular application of interest. So you can connect your PVs with your top level screens through the AOI system. And through your startup, you can say, okay, yes, that was loaded from this database file. So now you have AOIs associated with DB files or DB instances and so on. So AOI MEDM, to finish off on this screen then, this page, it basically exists to list or look at the MEDM screens that are related to the AOIs. And this particular tool requires complete AOI names. You can't specify wildcards here. But AOIs can have multiple top-level screens associated with them. And actually, they can even have things other than MEDM screens. They could probably have strip tool configurations and even alarm handlers, I believe. But I don't know whether AOI MEDM will only start MEDM. I don't think it starts the other tools. This tool doesn't actually work outside Helios at the moment because there's a PV gateway address in there that needs updating. But basically, you can use this to start the screens associated with that particular application. And again, with this one, you can also specify a PV name if you want to identify this AOI from the PV name, not from. So in fact, you can use the AOI MEDM -P and give a PV name, and it should give you should start an MEDM screen that's related to that particular PV if there are any screens in the system marked for that. I didn't actually finish covering off here, so the -P option, in this case, I can use a wildcard, the % again, to find out multiple. So this is only a partial process variable name, and it will basically list all the AOIs. Usually there's only one AOI for each PV, though. So. But no, they are hierarchical, so there can be multiple AOIs for a PV. Sorry, yes, that is right. So you might have multiples, but you have to pick. In this one, you would have to pick one of those. So if you use the -P option and it gives you multiple AOIs, it basically tells you I'm only using the first one. It gives you get a message up there that says there are too many AOIs here. I'll only open one screen. I don't know. Are you guys keeping AOIs up to date? I noticed some IOCs do. NIC's IOCs I think have AOIs, but some people don't. So that's those things may be degrading, but they could still be useful for some applications. That is my last slide on this. I know there are a few other tools in the iocappsTools area. There's one that starts and kills soft IOCs, which presumably, I don't know whether you guys use that when you're doing that, or whether you do those kinds of things manually. But those are the main. Let's just go back. To So there's a few here. So CA clients is a tool we wrote back which actually allows you to see what channel access clients are running on a particular machine. Control log is wrong. It implies that it can send. It may be that we used to have a list server associated with the controls logbook, but we don't anymore. I guess I've covered most of the other things there. Oh, IOC code change is an interesting one. If you're needing to find out which IOC applications have had modifications to their database files or startup scripts, that seems to go through the files, at least the active boot files, the DB files, and the st.command files, and allow you to query which ones might have changed since a particular time. So if you're thinking somebody made a change to this application, when and what has changed since that particular date, that might be a useful script. I don't have the rest of the list there, but there are a useful set. So this IOC help can give you a list of what the other tools are if you need them. Any questions? Nope. Okay. Well, thank you very much for coming. That's all I have for today.